Hi guys, this is Mrs. Discavich. I want to go through a few problems with you using Avogadro's number for mole conversions. Remember, Avogadro's number is 6.02 times 10 to the 23rd. It doesn't matter even what you're talking about. You could have 6.02 times 10 to the 23rd pieces of candy. You could have 6.02 times 10 to the 23rd atoms. You can have anything of that number because 6.02 times 10 to the 23rd is 1 mole, period. So let's take a look at where we are in our conversion chart. So if you look here, we are at atoms, moles, particles, and formula units, and we are simply doing a one-step equation to moleville. And so in order to get there, we're going to use here is Avogadro's number. So to get back and forth, that's how we go back and forth between this. A lot of students like to get Avogadro number happy and use Avogadro's number for everything. Be careful with that. You only use it when you're converting from atoms, molecules, particles, or formula units to moles and back. Let's go on to some questions. The first question is, how many molecules would be present in 4.2 moles of glucose? Now, if you guys wanted to, you could pause and stop the video for a second, try this problem, and then I'm going to just show you how to do this. So what we have here is 4.2 moles of glucose, and we want to know the molecules. So it's important to identify what you have given to you to start with and what you're looking for. You always start with what's given to you, which in this case is 4.2 moles of glucose. I always write, you don't have to at this point, but I usually write what we're working with. I always write moles. But when you get in that good habit and you get to stoichiometry, you're going to be grateful that you did. So I'm going from moles to molecules. The reason why I'm using molecules in this case is because glucose is a covalent compound and it's a biomolecule. You should remember that from biology last year. So for every 1 mole of glucose, C6H12O6, I have 6.02 times 10 to the 23rd molecules of glucose. So I'm going to be able, the reason why I put moles on the bottom is because moles is on the top of the prior one and I can cancel. Now notice what we do is we always multiply across the top, multiply across the bottom, and divide the two. So in this case, you're basically just multiplying across the top. And while we're at this, I'm going to change my pen color really quick. Let's just go white. That'll be better. When you punch this into your calculator, this is where half the problem comes in. So many students have a hard time punching into their calculator, which I know it sounds crazy, but if you don't use like the proper notation or if you don't use parentheses, it can go awry. So you're going to put in 4.2, there's two methods to do it, times parentheses 6.02 times 10. And some calculators have a caret. If you have a graphing calculator, you probably have just to the power. What I like to do is a shorter method where you take 4.2 times, and I don't have to use parentheses here, 6.02, and there's an EE button on your calculator, and oftentimes it is second function, but look for the EE. One E will come up on your screen when you hit it, and that's sufficient, and then you punch in 23. Either way, I want you to punch that into your calculator right now because I want you guys to see if you are getting the correct answers and if you're punching it in correctly. So you get in that good habit. So the answer is 2.53 times 10 to the 24th, and that answer should be written in molecules. So again, please make sure you're punching this into your calculator. So that truly is half the battle with us teachers trying to teach you guys this, because we'll see it right on paper and then you'll get it incorrect. Let's take a look at another problem, and this time we're starting with atoms of copper and we're converting to moles. We're still using Avogadro's number here, but we're just going to go a different direction. So we start with atoms and we need moles, and we always start with what we have. And so we're given 3.45 times 10 to the 22nd atoms, and we're working with good old copper right now. All right. So this time, we're going to actually put Avogadro's number on the bottom because we have 6.02 times 10 to the 23rd atoms. And we need to put it on the bottom because so we can cancel from the top of our previous section, and that's for every 1 mole. The reason why we put 1 mole on the top is because it's equivalent to 6.02 times 10 to the 23rd, which is on the bottom. So you're always going to find the top and the bottom of these factor label methods. They're going to be equivalent to each other. Now this time, notice there are ones on top and ones on the bottom. So essentially you're dividing because we take everything across the top, 3.45 times 10 to the 22nd times 1, which is the same, divided by Avogadro's number on the bottom. So again, I would like for you guys to punch this in your calculator so that you're doing this correctly. And you should get something like 0.057 moles. And that's how many moles of copper. Notice that's a small amount of moles of copper, but that's still a substantial amount of atoms. Let's go on to the next question. How many moles are in 4.78 times 10 to the 24th formula units of calcium carbonate? The reason why it's formula units is because calcium carbonate is an ionic compound. So we can't really say molecules because we don't use that terminology for ionic compounds. So we're going to start out again with what we're given, which is 4.78 times 10 to the 24th, and that's formula units. So instead of writing them all out, oftentimes I write formu, so it won't come out as something not so pleasant. So we still have formula units. We still use Avogadro's number. So we have 6.02 times 10 to the 23rd, and that is formula units is in 1 mole. So again, here I put it on the bottom so I can cancel formula units, and I can't cancel mole is because I want to convert to mole. So I'm going to divide again, 4.78 times 10 to the 24th, and I'm going to divide that by 6.02 times 10 to the 23rd, and I'm going to get 7.94, which in the big picture is pretty good amount of substance, because 7.094 moles is quite large. I know the number sounds small, but when you're talking about moles, that's a decent amount. So you guys, the biggest thing is just to make sure you can cancel your numbers, make sure you punch everything into your calculator correctly, and just practice. This just takes practice.